Well, thank you for joining us today. Now I'll pass it over to Shruti.
Okay.
Speak a little slower and a little
Okay.
louder. Thank you.
So thank you again, everyone, for joining. And sorry, I could not hear anything in the past. So I don't know what exactly happened. But anyway, we are on track now. So maybe I'll just do a quick introduction of myself. My name is Shruti. I'm the general manager for Blockchain Center Singapore. We are a blockchain knowledge and community center. And in my previous life, I was actually working in the healthcare industry. So I worked in healthcare consulting as well as in the pharma industry for almost 15 years. So therefore, I have a very strong interest in healthcare industry as well as blockchain. I will introduce the other speakers as we go along, but just to give you a quick overview, we have very experts from A-Star, Lee Zhengqiang, as well as Ernie, who is joining us from JetTrade, and Dr. Sean Lam will actually join us for the Q&A as well. And I'll share more about them later. So moving on, just a quick overview of, I'll turn on off my camera now. Uh, so that you can probably, there's less of a lag here. So let me just do that. So just a quick overview of, okay. So what I want to do now is just to give you a quick snapshot of what is happening in the healthcare industry, at least from the perspective of the role that blockchain can play and the challenges that we have in healthcare that can be solved using blockchain. And also just to give you a very quick overview of what blockchain technology is. My goal is to basically give you a very simple 101 version of what blockchain is. And later, Dr. Ernie Teo and Lee Zhengqiang will actually go into more details and we can have a more in-depth discussion then. So, digitization in healthcare. Digitization has basically been a very important step towards transforming healthcare. So as you're probably aware, we have now hospitals and clinics that have our electronic health records, which record our medical histories, treatment plans, and many more data points. We have wearables and health apps, which can actually track a lot of vital parameters. We have insurance companies and payment providers that have our health data so that they can design better products. Research institutions now have access to this data so that they can identify the right patients for clinical trials and research, as well as manufacturers who actually have access to our data and are able to design better treatment and products for patients. Um, all this is actually built on very strong databases, softwares, and privacy laws. But what has happened as a result is that these have also created many data silos within the healthcare system, which have also to an extent taken the power away from the individual patients in the hands of these entities which actually hold all the data. So what we have now in the healthcare system is a scenario which is where data is highly fragmented. So like I said, there's several data silos that are actually capturing our health profile. Um, there's a lot of friction in data access to have data transfer from one entity to another. There's a very high risk of data security because these our health profiles are actually held in very often in centralized databases. Um, their data analytics is still quite inoptimized simply because it is distributed across so many different parties. The claims process is very prone to inefficiencies as well as fraud. Our supply chains still have a lot of counterfeit drugs. Clinical trial processes are still not optimized in terms of patient enrollment. And the clinical data that comes out of a lot of research and trials is often questionable in terms of integrity. So what does blockchain do, or how it can really help? So just to shift maybe now gears to what the technology is, and then we can blend it all together in the next presentations. So blockchain is basically a network of a decentralized peer-to-peer network where there is no central authority or intermediary to manage this data exchange or transfer. Why it's called a blockchain is simply because it comprises of a chain of blocks, and what each block actually contains is a set of transactions or data records which are linked to each other by encrypted code, and is time-stamped. So the data is arranged chronologically and encrypted within each block, and then linked to the next block, also using encrypted code. And this transaction or record can be anything. It can be it can be data, it can be an exchange of value, or any asset of value that can be recorded on a block using encryption. So how does blockchain really work? When a transaction is initiated, and again, like I said, the transaction could be an exchange of data or exchange of an asset of value. The transaction is basically broadcasted to a wider network of peers, or a peer-to-peer network. And these peers, or what we call nodes in the network, validate the transaction based on a protocol that has been agreed upon to arrive at a consensus on whether this transaction is valid or invalid. And once the transaction is verified, it becomes part of a new block with the use of encryption. And this block is then added to an existing chain of blocks which capture the entire history of the record or the data that is being transacted. And once that block is added to the existing chain, the transaction is considered complete. So there are many words or terms that we associate with the blockchain when we talk about the blockchain. So we say that blockchain is secure, it is transparent, it is immutable, it is trustable. So what does it all really mean? So security. What makes blockchain secure? Unlike a typical or a traditional database where there's a central server, data in a blockchain is actually distributed across a network of nodes. So instead of keeping the data on a single server, the copy of the same data is distributed across several network participants, which helps avoid a single point of failure or a data breach in worst case scenario. And that distribution or decentralization of data basically makes the blockchain extremely secure and difficult to breach. Transparency. So why do we say that blockchain is transparent, at least in the case of a public blockchain? So this is a screenshot of a transaction that happened on the Litecoin blockchain in 2018. And what you see that is highlighted is a transaction that happened on 17th of May 2018, where about 700,000 Litecoins were exchanged, and the value was $96 million. Now, when I say transparency, what that really means is that you can actually see the exact transaction that happened between two parties, the value of the and as well as the value of that transaction in both volume and dollar value. But what's even more interesting is that this transaction happened of $96 million in 150 seconds, and then the fees that was paid was as little as 40 cents. So which basically is trying to demonstrate that blockchain is not only transparent, but it allows for transactions at very high speed as well as a very low cost. So blockchain is immutable, and what do we really mean by that? As I shared earlier, how the blockchain really works, when a transaction is initiated, the data is encrypted before it is actually broadcasted to the entire network. And also, once the transaction is verified by the network, it is again encrypted before it is stored in the block or of the ledger, and then further encrypted when the block is added to the existing blockchain. So with this extreme encryption and levels of encryption, it makes it very difficult for a bad party to actually de-encrypt or hack uh, into the data or the record that actually exists. Trustable. So why do we say that the blockchain is trustable? And that's when the smart contracts actually come in. A smart contract is basically nothing but a set of codes or commands that allow a transaction or exchange to happen without the need for a third party or an intermediary. So it's basically a contract between two parties that actually self-executes itself when certain conditions are met. And why that really is helpful is because in many cases where the two parties are unknown to each other and there's lack of trust, these contracts and transactions can actually occur if simple conditions are met. And in a case of, for example, healthcare, this is very helpful because in healthcare, the lack of trust is a very big issue. Whether it is right from the government all the way to the patient, a lot of the laws and regulations that are set are simply trying to address the problem of lack of trust. And therefore, in a scenario, having a blockchain can really address that issue as far as healthcare is concerned. So that's just a quick snapshot of what blockchain is and what are some of the characteristics of blockchain that make it so such a valuable technology. And with that, I will now pass on to Xinxiang to actually share more about the work that he is doing. And just to give you a quick introduction, so Dr. Li Xinxiang is a group manager and a scientist at the Institute of High Performance Computing at A*STAR Singapore. He's a member of various A*STAR cutting-edge programs to develop secure, efficient, and scalable data sharing and processing platforms for multiple industry domains. Xinxiang is also a principal investigator of several industry projects involving multidisciplinary collaborations and real-world applications. So with that, over to you, Xinxiang. And I understand that I haven't taken any questions, but I think we can actually do that after his presentation and cover everything together. So over to you, Xinxiang.
Thanks, Shanti. Thanks for the introduction. So this is Zheng Xiang. So sorry, apologize for just the connection problems. I'm from Institute of High Performance Computing on the A*STAR. So today I will introduce our system prototype using blockchain for healthcare applications, or more specifically is the EMR data sharing across different hospitals and research institutes. As Shanti has mentioned, the blockchain technology have these four main pillars to support that. First one is distributed ledgers. It means that different parties will have their ledgers, a copy of the ledger, and then they will keep this consistent using the consensus protocols. And besides the data storage on the blockchain, there was also smart contracts introduced in blockchain technologies. Then smart contract can be triggered by some conditions, and then they will automatically run, and then based on the blockchain data and do some automatic workflows. Last but not least is the incentive. So especially some of the public blockchain have their built-in cryptocurrencies. So this can be a very good incentive mechanisms to incentive owners and incentive participants in the blockchain. And depends on how deep dive to the blockchain core technologies. We can classify the blockchain technologies into different kinds of groups. From left to right is the deeper and deeper we touch the blockchain core technology. First one is applications. For example, you just use some public blockchains API to develop some applications. Then the second one is deployments. It means you have to deploy your blockchain platform. Either you use some open source blockchain platform, something like Hyperledgers or Ethereum. And the third one is integrations. It means we have not only use blockchain, we have used integrate blockchain with other technology together to develop the whole systems or deliver solutions. And then go a little bit further is enhancements. They enhance the performance, security, scalabilities, and privacy of the blockchain platforms. There are a lot of researches ongoing to do that to push the blockchain technology forward. Last but not least, creations means you will create a new blockchain platform, something like besides Bitcoin and Ethereum, there was a lot of new public blockchains coming and private blockchain coming. Yeah. So in blockchain platform itself, also have different categories. So this table have divided blockchains into three groups. First one is public blockchain. That's usually you have very familiar already. Bitcoins and Ethereums. This one can allow anyone to join the blockchain to maintain the blockchain as a miner. A private blockchain and consolidated blockchain we are also calling permissioned blockchain. It means that only the person or organizations are permitted with their identity can join the blockchain, can maintain the blockchains. Okay. So we are more focusing on consortium blockchain because the consortium blockchain is more emphasized collaborations across multiple participants. For example, in healthcare domains, there are hospitals, they have research institutes, they have insurance companies, all of them are different stakeholders. They want to do some collaboration together and build some trust ecosystems. So the consortium blockchain is mainly for this purpose. In addition, consortium blockchain can also play a good trade-off between the securities and the performance. The performance definitely is much, much higher than the public blockchain in terms of the throughputs, scalabilities, and so on. Here, this slide gives more details of the typical consortium blockchain we call Hyperledgers from Linux foundations. The fastest, the latest research, now we can achieve about 20,000 transactions per second. So the system design is quite different from the public blockchain. You are already familiar with Bitcoins and then the Ethereum. So it's more likely the modular or configurable architectures, neither distributed systems. So it don't have the native cryptocurrency as well. It saves the cost significantly. Yeah, so this figure shows the main architectures. They will do the executions, and then after that, they will do the endorsements according to the policies or majority voting, and then they submit the transactions. And then the order will do the block, generate the block. And finally, the block will be committed and validated by the blockchain level. As I mentioned, blockchain technology is not standalone. Blockchain technology have to integrate with other technologies, something like IoT, digitalizations, and AI, and also everything put on blockchain. The data is already transparent, so there was big issues to think about the privacies. So how to integrate with privacy technologies, integrate with blockchain together to fulfill some real applications requirements is also a very, very challenging issues. After converge all these technology together, we will create a tangible platforms and then consider about the performance, scalability, security, and then privacy issues. Finally, this platform can be applied to different application domains, from the transportations, insurance companies, and healthcare, manufacturers, and so on. Yeah, so our team have built some system prototype for different application domains. But today I would like to share more about the healthcare domains. As Shanti have mentioned, the existing the medical data sharing is very fragmented. It means the hospitals, they have their own database, they cannot share the data with each other. So for example, if you take X-ray, the MRI in what hospital A, you can, after that you go to another hospital, you cannot get the data, cannot access the data freely. So in lack of the data linkage, and also very complex regulations and absence of automations, and as a result, the data is very fragmented and scattered among the different hospitals or different countries. And to ensure the data, you have to do the data sharings, you have a very complex administration and human interventions and so on. So if we use blockchain, then we enabled all these stakeholders, hospitals, governments, universities, and insurance companies, they will maintain the blockchain as a consortium. So it means all of them will have a copy of the ledgers. They will record where is that, who have the data, who have shared the data, who have accessed the data. All these transparent, and then they will build a trust about the data sharing and return the control to the patients about their data. This figure shows more detail of the design. So from the in the right hand side of the figure is the consortiums who are maintaining the blockchains. So they have smart contract layer as well, besides the ledgers, that is all the records. So from the right hand side is the users. So the data owners will publish their data on their blockchain, and then the data requester will be informed or be notified about the data available in the consortiums. So they will send a request of the data, and then data owner will grant the permissions to the data requester to use the data. Yeah. The data itself, because the data itself is very big, usually is, for example, the MRI, they have thousands of images. So in this case, this data, we cannot save this data on blockchain. It's very costly and very heavy. So we will save these data on off-blockchain storages. And how to secure this blockchain? How to secure these data on this off-chain storage? We have to do the encryptions. And all these encrypted, all the data stored here are encrypted. And then the key will be transferred through the blockchain. The key will be encrypted by the requester's public keys and then secured, ensure that the data can be accessed by the requester only. So based on this, on-chain and off-chain orchestrations, we can track all the data access, data shares operations in the ecosystems. And in the meantime, we will do the data encryptions, ensure that the data is accessible by the granted data requesters. This figure shows more details about the implementations. So they have the blockchain layer and the service layer. Service layer, as I mentioned, they can do the permission grant service. Permission, you can declare your permissions as well. And then there are some provide some API for the application developments. On the blockchain side, they have maintained their participants, access, and then access control. Access usually is the data to be shared. So we have do the demonstrations based on this system prototype. So as patients and doctor can do the registrations through our applications, and then the patient can share the data. And after that, he may receive some request from the doctor, and then he can grant the data access. then the doctor can download the data and use the data. And if the patients, maybe after certain time periods, or if the patient don't want to share the data anymore, he can also decline the data access. Yeah, he here shows the prototype interfaces from the patient's interface and the doctor's interface. So patients, you can send the request, and then the patients can do the allowed and decline the access. And finally, the data from the patients to the doctor. Just the details about the blockchain transactions, that which is allowed documents. If access control also will be recorded on the blockchain. So all this information will be transparent to the whole consortium. So this is very important for the future auditings or future evidence if there's any data leakages, or if the doctor abused the data. Yeah, so this is the first part. I have introduced our system prototype for the EMR data sharing across the different organizations. So in return, the data access control to the patients. In the remaining part of my presentation, I would like to introduce one of my collaborators' work from Taiwan, Prof. Chen Kong. He is developing similar systems enable EMR data sharing. However, this system is already pilot systems and go to live already. So that is why quite impressive. So in the remaining slides, I will introduce a little bit. In this systems has been applied in Taiwan. In Taiwan, the existing inter-hospital EMR data sharing is still very, very painful. So you have to go through the centralized national EMR exchange center between the hospitals, and also it required very complex authorizations from the patients, and then highlighting signatures. So my collaborators, Chen Kong, have already built systems based on Ethereum's public blockchain. They have enabled the patients to do the authorization form, and then to authorize the doctor to access their data. So the data itself, all the EMRs, similarly, all these EMR are not safe on blockchain, it's safe off chain. So the EMR are remained in original healthcare institutions. But they have the centralized index to increase the data visibilities. And also the data access controls is controlled by blockchain, use smart contract, and then all these operations that cause access controls will be handled by blockchain. If we have all do these data sharing using smart contracts, so we can remove a lot of human interventions. So we can achieve a very fine-grained controls. For example, we can do what kinds of data can be used, and which hospitals, periods, and so on. So all this can be implemented in smart contract and controlled by smart contracts in the automatical way. And these systems, as mentioned, these systems have been pilot systems and go to live already. Yes, so there was one very impressive use case, is that there was a county offside of Taiwan. So some of the patients, if they go to this, when they are doing visitings or they have visited relatives, then they can authorize the local doctors to access their data in the hospitals in Taiwan. So this is quite impressive use cases. So it can sign the users based on their handphone. They can they can authorize the data access anywhere, anytime. And then the doctors can access the data from anywhere. Yeah, so in general, so besides the EMR, these systems, blockchain can govern the data sharing for different kinds of data. So for example, in healthcare data, the healthcare data is also very, very important for research, doing the analytics, AI, and data visualizations. So this figure, left-hand side is the traditional data sharing from the data owner. You can share either centralized one or decentralized data centers, and then that to the data consumers. Then if we have the blockchain, we can governance all these data sharings to record down who have which data, who have accessed the data, who have granted permissions during which time periods. All this will be implemented according to the rules and agreements using smart contracts. And then the data, the record, the data informations, access right and usage records will be saved in the immutable distributed ledgers. So it can support future auditings and evidence. So in this case, it can do some data integrities and discoveries to transfer the data's ownerships and immutable fine-grained data access, which has been already demoed in the pilot systems. And based on this data sharing, we can enhance the AI's powers with the shared data, and also maybe we have to discover a new business models in healthcare domains. Thanks. That's all I have today to share.
Yeah, I actually thought maybe we will, because I prepared some questions as well, but maybe it's good to also get some questions from the audience first. So the first question is, in a EHR system like that we have in Singapore, for example, how do we actually deploy a blockchain solution if the existing EHR is deemed as a national information resource as opposed to a patient's private record?
Okay, I didn't see the questions you mentioned, but I would like to address the last questions and thought is the blockchain is used here is public or private. In my presentation, I have shared two blockchain prototype for healthcare data sharings. For my first one is based on Hyperledger, that is a private blockchain. For the second one from Taiwan, the one is based on Ethereum, based on the public blockchain. So it really depends on their requirements. Both of them can support the data sharings, have the main features, something like immutabilities, auditability, traceabilities, transparent. Yeah.
Yeah, I just chime in on Shruti's question. Shruti is very right that the EHR system, somewhat in the West as well as for Singapore, we are using really well-established systems like Allscripts, the SCM, Epic, which is next generation EMR and so forth. So my take is that to really put the data on chain, it may be not so straightforward. So it actually concerns the architecture of the entire EHR. But if we take small bites out of it, right? Like I shared with Dr. Lee as well, if we are just looking at the approving process or the consent processes on chain, that could potentially be a low-hanging fruit rather than upfront we are talking about data on chain. So it's just the consent process that is on the chain, and it's likely going to have to be a private chain. And where is the best areas that we could look at for low-hanging fruits? Potentially is for secondary users of the data, not the primary users, which is for clinical care. Because for primary users, I think Singapore legislation requires the healthcare institutions to share data. And I guess all of you may have heard of the NEHR system, the National Electronic Health Record, that really contains the ability for our data to be portable across different health systems. So that is really to provide and protect the patients, to provide the best care. But we are talking about secondary purposes like research and innovations. We got to go through a pretty lengthy process to get the approval under the HBRA, under the PDPA. So to a certain extent, it potentially could work, but it's really maybe covering less than 10% of what blockchain is capable of. But that is operating under the governance structure that healthcare system has to abide by. That's my take on this ability to implement in the EHR system.
Thank you, Dr. Sean
Okay.
Lam. I actually should maybe just do a quick introduction. So Dr. Sean is actually is the head of data science at Sing Health. And thank you for actually addressing that. Fernice, do we have any other questions or time for more questions?
Yeah, could we address one of the higher upvote question? Why can't a consortium create a solution using non-blockchain technology that has a lower entry level versus blockchain, and what actual benefit does blockchain offer a consortium? So that is, if you were to look through the Q&A, I think that's one of the person make this question. Just have a look at it. Could we address that question, please?
Okay. May I try to address the question?
Yes, thank you.
Yeah. So it's possible we can build a consortium if we can build a consortium, not blockchain technologies. Actually, the data sharing is happening without blockchain. Even blockchain has been coined. Blockchain technology has been coined. Yeah, but blockchain technologies actually is try to build a consortium with no cost. Actually, if you in my introductions, if we go for private blockchain, the cost has been reduced dramatically. So you can treat this as a consistent and cryptocurrencies, cryptography enabled consistent distributed database. So in this case, it can increase the transparency and can reduce the cost to build the trust in the consortiums. So this might be one of the advantages using blockchain to build a consortiums.
In fact, this was actually discussed extensively, and there's a need to really leverage on blockchain. But I see the vision. I also see the way forward is actually not so straightforward. So the vision is actually, I mean, to myself personally, I would think that the question when we ask this question about data ownership, right, for patients or electronic health record, if you were to ask me who the data belongs to, currently we will say that it belongs to the institution, then the treatment from, it belongs to the health system, it belongs to the hospital and so forth. But the vision, realistically, I will speak, I mean, to be fair to the patients should have a direct control on who uses the data and for what purposes. But obviously, patient may not have the knowledge for clinical care. So clinical care may still be legislated, meaning that we need to know the patient's data over time and how the disease progression is like for the particular patient. If we have patient that refuses for us to share data across health system, it will inadvertently affect the patient's care considerably, because we have pieces of information or gaps in the knowledge of that patient that we cannot make use for to provide better care. So let's put care aside. Let's talk about users that the patient has not consented to. Say, for example, research collaborations with ASAP, for example. Those, I believe, I think the patient, I mean, from a very strategic vision perspective, the patient should still have a say. Meaning that I do not want to participate in this particular HIV study, for example, unless I really sign up. So like clinical trials, the patient will have consented for. So for those, right, if we were ready to look at the use of this traditional system like SQL and all those, it's going to be technology that may be too far back. I mean, the technology is not there to really deploy efficiently and effectively. So blockchain may be a solution. But like what I said earlier, it may be hard because from an infrastructure perspective to immediately consider blockchain. And obviously this kind of whether SQL-based solution or traditional databases, definitely they are still being used. So to a certain extent, I think if we were to look at the way forward, it may be a hybrid solution until a time where it's clearer on what Singapore can pursue from the health system perspective. Another point on Taiwan, right? My understanding is Taiwan system, they are a couple, or I don't know whether it's large part of them, they are homegrown solution. And China is really leveraging a lot on Taiwan's technology in EHR, from my understanding. So they have control over their EHR system. We leverage heavily on these big enterprises, and they are well known to be kind of like impenetrable fortresses. If anyone would like to try and do something, you have to true partner them, or we have to think of others. That's why a lot of startups fail, and blockchains, there's a lot of startups involved. So I kind of like go beyond the question, but yeah, I do agree. Why can't we just create a simple database, and it could be a hybrid solution, for example?
Right.
Yeah, that's my thoughts.
Thank you, Dr. Sean. Fernice, do we have time for one last question?
No, unfortunately we don't have, but we do have a record of all the questions that I would share with you guys, and if needed, I will also share the speaker's email. So if you like to connect with them, please do check out your email hopefully by end of today. Then we'll move on to the next section now. Okay, Shruti, I'll leave you to introduce Dr.
Sure. Thank you, Dr. Lee, Dr. Sean, and let's move on to the next section. So Dr. Ernie Teo is joining us from Jetrade. He's the blockchain advisor at Jetrade, and he has over a decade's experience in economics and technology research, and executed several projects in his prior capacity at IBM Center for Blockchain Innovation. He has also published in the area of blockchain and fintech, most recently in the 2018 IIIE conference.
Thanks, Shruti. Hope everyone can hear me fine. Just say hello. I'm going to turn off my video now so that you get a better streaming. So, okay. So today I'm from Jetrade. So Jetrade, we are kind of a solutions, blockchain solutions company that's been developing several different types of projects for different use cases. And of the use cases that we have done, a few of them are in the healthcare area. So I'll be talking about some of them today, and I'll hopefully be able to also show you some demos that we have made as well. Right. So the key in this slide, what I want to emphasize here is why the use of blockchain is so big in enterprise now, and why all the technology departments are trying to look at this. It's because 83% of executives believe that trust will be the cornerstone of the digital economy. So our focus here today on the use of blockchain is about trust, and about how blockchain can enable the trusted sharing of digital information, right? And that's also the focus of our projects that I will show you today, how we create that trust and how we enable sharing to happen. Right, so one of the first use cases that we've done that's related to healthcare is actually for a DNA analytics company. So we created a platform, a proof of concept platform, to allow them to share DNA data with third-party service providers. So so this is a prototype that we've created. So you can imagine by allowing sharing of DNA data, we can create a kind of a third-party services marketplace based on this data. For example, we can create markets for customized healthcare supplements, or customized fitness plans, customized dietary plans, right? So, but of course, your DNA data is sensitive, and you can't share that outright. So what we did with this use case is we created these secure execution environments. So the data that is stored on the blockchain is fully encrypted, and the service providers can only ask the data questions through this environment. So for example, if I'm trying to create a customized supplements for you, I will ask the data, whether your DNA means that you're likely to benefit more from omega-3 or omega-6. So, and the data will return these answers to me, which allows me to customize these supplements for you without actually knowing your actual DNA, right? And of course, your raw DNA data could contain things like whether you are prone to getting mental diseases and stuff like that, which you do not want to share. Right, so this is one example of our trusted sharing of data. So this demo is a bit lengthy, so I'm not going to go through this demo today. Instead, I'm going to focus on the second use case that we have, which is on the trusted sharing of medical documents. This is also a easier to understand kind of use case. So in a lot of medical documents that sorry, a plane just flew over my house. So for trusted sharing of documents, so like when it comes to medical documents, we can really think of a lot of use cases in the healthcare space where documents need to be trusted. And a lot of times, of course, this mirrors in a lot of other industries as well. A lot of times you are required to produce a paper document with a company stamp on it and with a physical signature from your doctor in order for it to be trusted. Right, so I'm going to show you two use cases today, one on medical certificates and one on prescriptions, to demonstrate to you how we create systems for these sharing to happen, and to allow, and the main motivation behind this is also to drive real digitization, right? If we want to digitize something, we want to be able to eventually not need to print it out, not need to get a piece of paper with a physical signature on it. Right, so let me dive straight into the demo. So the first demo I'll show you is for medical certificates. This is purely a kind of a sample that we decided to do for our JetTrace enterprise platform. And the medical cert is one kind of demo that we have created to demonstrate how we can create trusted documents through blockchain. Right, I'm going to turn on my screen sharing. Hopefully, everyone should be able to see my screen. Okay, so this is a JetTrace platform called Jet Enterprise Solutions. On this platform, the value proposition here is if you are a medical doctor or a clinic, you can register to use this platform and to issue medical certificates. So, but of course, if you want to issue medical certificates, you have to prove to the platform that you are a valid clinic, a valid doctor. What we will do then is that we will create a blockchain identity for you. So this solution is totally deployed on the Ethereum blockchain, which is a public blockchain. So our platform creates a blockchain identity for you, and it allows you to issue medical certs. Right, so a medical cert will look like this. So imagine I'm a doctor now, and I'm creating a medical cert for John White, right? So he visited my clinic for 3 minutes. I'm going to give him 2 days of medical leave, right? And I'll put in fever as comments here. So once I've done that, and I will be able to preview the medical cert. And once I'm sure of the data, I will create it on a blockchain. Now here you see a pop-up. This is actually, because this is deployed on the public Ethereum blockchain, there's a transaction fee, and a fee will be paid on the public blockchain. Now once this is paid, it goes into the blockchain for consensus, or for the blockchain to agree on this transaction before it's deployed. So you see it being created here. What we have done is we have used smart contracts to be kind of a holder or a fold. We use the smart contract to create a folder of sorts on the Ethereum blockchain, and these medical certs are stored on the Ethereum blockchain. Now, what is actually stored on the Ethereum blockchain is are only parts of the medical cert data, which allows us to verify the authenticity of the medical cert without exposing the personal information of the patients. So here you see there's a download button. I've downloaded the medical cert. So I can click on it to open the file. Here you see what the actual file looks like. The file contains various different information here. Right. So now going back to this, we can also look at this file on Ethereum. Right. And if we look at this file, we can actually see the content that's been stored onto the Ethereum blockchain. So here you see some gibberish. This is the name and name of the patient, which we have hidden with encryption. And we have also hidden some other pieces of data, but some of the data remains publicly viewable. This is also meant to allow different parties to validate this data. Okay, so once we've created the medical document and downloaded it, so I can then as a doctor, I can give my patient this file. My patient can then give this file to his employer. Now, his employer need not be a member of our system. He can come onto our website and go to verify. So verify does not require you to sign into any platform. Okay, and I need only upload the file that was given to me earlier, and I can click on the verify button to retrieve the same information and to have it verified by the blockchain. Now, let me give you an example of the anti-tampering use case, right? So if this patient wants to extend his medical leave, instead of having 3 days, he put in 7 days, right? And he tries to change the file. So he saves this file and he gives it to his employer. But in this case, if the employer tries to verify this file, he will see that it has been tampered with, right? And it's not the original medical cert that was issued by the doctor. Okay, so that's the use case for MCs, right? So in this use case, only trusted practitioners are given blockchain credentials. The medical certs are issued directly on the blockchain. The patient receives digital medical certs and gives it to the employer. The employer can directly verify the file on the blockchain. Okay, the next use case I have is for e-prescriptions. So e-prescriptions, so this project is done together with a e-doctor service here in Singapore to help them create a prototype of potentially using e-prescriptions on blockchain for their solution, right? So of course in Singapore, because most clinics directly dispenses medication, so there is less of a use case for e-prescriptions. But in an e-doctor case, where after you've seen an e-doctor via app, you may want to visit a pharmacy on your own to take out the prescription. So in this case, we work together with e-doctor service, and we experimented with putting prescriptions on blockchain. Now, in this use case, the solution is not deployed on the Ethereum blockchain. Instead, it's deployed on a private implementation of Ethereum that was put on Amazon Web Services. Right. So let's look at the demo. Right. So if I am a doctor, I can go into this demo and I can create prescriptions. Right. So here, if I click into one of these prescriptions, I can see the medications that I've dispensed, and I can see how much has been prescribed to this patient as well. Right, so to show you an example of creating a prescription, here we can add new medications into the list. So for example, paracetamol, 14 capsules, 1 capsule 2 times a day for 7 days, right, for fever. Right, so I can then add this prescription, add this medication. I can add several items into this prescription as well. Once I'm done, I'll confirm the prescription. Okay, and the prescription will be issued. Okay, sorry, I clicked too many times. Yeah, so we see the new prescription being issued here. Now, what happens then is this will mirror onto the patient's app. Okay, so here you see the patient's app on the mobile phone. Okay, we see, so if I refresh this, you'll see the new prescription that was issued earlier, right? And I can click onto the new prescription. Oh, sorry, this is different one. Okay, so I can click onto the prescription, right? Now, when taking this prescription in my phone to the pharmacy, what I will do is I will click on this QR code icon here to produce a QR code. And the pharmacy will be able to retrieve my prescription via this QR code with my permission. So let me demo that now. Okay, so now I'm moving into the pharmacy view. So pharmacists will not be able to see any prescriptions unless they have either dispensed the medication or they have the permission of the patient to view this prescription. So so I'm going to turn on the patient QR code on my phone, and I'm going to actually scan my QR code via this app. Okay, so here's my QR code on my phone. Oops. Okay, once I scan the QR code, I will request permission. And this will trigger an OTP that will be sent via SMS to my phone as well. Okay, so I won't be able to show you my phone, but I've got the OTP. So I'll key in the OTP. Once I submit this, this means this is the action of the patient giving permission to the pharmacy. The pharmacy will be able to retrieve the prescription. Now, in this prototype, we also allow for the partial dispensing of medication. So here, for example, I can partially dispense half each. Okay, and as a pharmacy, I will submit this, and the medication will have been dispensed. Right. So so now if we move back to the patient's view and we refresh this, we will see that half of the medication has been dispensed. Right. Finally, let me show you how it will look like if it's fully dispensed. We will see a purchased status, and the patient will be able to see that it has been he will not be able to use this prescription anymore to buy any more medication. Right. So the doctor will be able to monitor that his patients through this platform as well, because he can see whether his patient has took out these prescriptions or has partially filled them. Right, so that's the e-prescription demo. So this we just completed this prototype with the eDoctor service around early this year, but then unfortunately COVID-19 happened, so the eDoctor was also very focused on delivering help for the patients, etc., for the situation. So this so far has not been deployed and has not gone into production. Right. So with the e-prescriptions, we are dispensing medication with trust. Right. The eDoctor issues digital prescriptions on the blockchain. Now, this is a permission type blockchain, which means the eDoctor service can onboard doctors and pharmacies onto the platform. The people who make up this blockchain will be pharmacy groups, will be clinic groups, etc., who will be part of this blockchain. Right, the pharmacy will scan the patient's QR codes. The patient will receive SMS OTP. The pharmacy will get confirmation. They will be able to retrieve the prescription, and then they will be able to dispense and prescribe the medication. Right, so that's the different the few demos that I have. I'm gonna stop sharing screen now. Okay, let me move back. Yeah, so those are the demos that I have. Hope it was informative for you guys. So these two demos, although are still in kind of prototype and demo stages, they are fully deployed demos. They are working on fully working on blockchain. So this is just to give you a flavor of what are the kind of possible use cases out there for healthcare using blockchain. So what I've demoed are more kind of lower hanging fruit type of situations where we want to use blockchain to share certificates in a trusted way or share documents in a trusted way. The medical cert use case is very similar to a GovTech project. It's called OpenCerts. OpenCerts is a platform to issue education certificates. It is deployed with the major universities here in Singapore, and a lot of the students are receiving their diplomas and degrees via the blockchain as well. And it allows the employers to actually validate the authenticity of the degrees on blockchain. Right, so these are the two demos I have. Happy now to take questions. Okay.
Thank you, Dr. Ernest. I think there's a question here, so maybe we jump right into it.
Yep.
Do you take into account the workflow and systems used by private pharmacies? This is regarding deployment of e-prescriptions.
So can you repeat the question? I
Yeah,
can't
sure.
hear.
So for e-prescriptions, do you take into account the workflow and systems used by the private pharmacies?
Okay, so currently this is still at a prototype stage, so we haven't looked at integrating with the pharmacy's inventory systems yet. But what we have provided is a way for the pharmacy to retrieve a prescription the same way that they will receive a piece of paper prescription. And but then on top of that, we added a functionality for them to partially fill or fully fill these prescriptions and allow other people who receive this prescription in the future to be able to validate whether it has been partially filled or not. Right. Yeah. So we haven't really gone to the stage of integrating with the private pharmacy systems yet.
I see. The next one, this is with regards to data audits. So how do you ensure the authenticity of the data that is actually put on the blockchain? So how is data currently audited, and how do you ensure authenticity while it's put on the blockchain?
Yep. Okay, so for the medical cert use cases, the issuers are pre-screened before they're allowed to issue the medical cert. So they have to be a certified pharmacy, or a doctor. Now, in any case, the doctors or the clinics will be able to monitor the medical certs that are being issued out of their system. And in any time, if they see anything wrong, or as for example, a hacker has hacked into the system and been generating a lot of medical certs, they can inform us immediately, and we'll be able to turn off or shut down that identity and issue the clinic with a new identity. Right. So in terms of the audit of the data, it really is from the source of information. Right, so it's only as good as the source of the information. So we want to make sure that the issuers are trusted individuals before we allow them to issue the data. So the same goes for the e-prescriptions. Yep. Okay. So I'm just looking at the Q&A chat, and I see some questions there. I think the top question was, can you please tell us what is the technology framework used in the medical certificate project? Right, so the tech stack is actually the front end application is written in JavaScript. The back end is on public Ethereum using Web3 and MetaMask, which you saw earlier, which is a blockchain wallet. So it's integrated through so the front end is integrated to the back end through Web3, which is a kind of a service that is provided by the Ethereum Foundation as well to interact with the blockchain. Okay, yeah. So I think I've answered the second question in the talk. They are not actually deployed in real life yet.
There's one more question earlier,
Mm.
Ernie, which might be relevant to you. What is the cost of implementing a blockchain solution, and is the cost shared between stakeholders in the supply or value chain?
So I think again, this really depends on the architecture of the solution itself. So the two demos that I've shown here are really, we refer to Zhenxiang's slides earlier. We are really at the application level rather than at the network level. So the deployment of these are all on either a private blockchain that's deployed on cloud, which will then involve cloud hosting costs, or deployed directly into a public blockchain, which will involve transaction fees, right? But the estimated cost of sending one such transaction, like a medical cert, is around five US cents, so it's not extremely high yet. And if we compare that with transactional costs of other systems, it's pretty similar. In terms of hosting, the applications is the same as hosting any website, right? There's costs involved in hosting the websites. There's costs involved in making it secure as well. So those are the costs involved there, right? So because we are deploying this on public blockchains, there's no need for other entities to host nodes on the blockchain network. There's already a very large existing public blockchain network to uphold the integrity of the data. In a private blockchain case, then every stakeholder, so like for our prescriptions, if a pharmacy group decides to join this blockchain, they would have to host a cloud instance of the blockchain network, right? So the cloud hosting cost, I think our early estimates are around a couple hundred per month on AWS. So it's also not extremely high. Right? Of course, the cost of creating these systems are separate, right? Yep.
And maybe this is coming from somebody who's actually looking to deploy something. So would you be able to give a sense of how, how much does it cost to actually build something, whether it is maybe easier or more cost effective to do it with an existing solution like what JetTrade has?
Yep. So so to custom build blockchain solutions currently is still fairly expensive compared to projects. It can be in hundreds of thousands range. If you go and speak to any of the kind of blockchain development houses out there, right? So that's why at JetTrade we're also trying to push more modular and more more modular tools, blockchain tools for different stakeholders to use to issue documents and to do various different things on blockchain itself, right? So these tools will be charged on a more subscription-like basis. I think this is also the trend that we see now going on in the market. There are various players that are offering blockchain as a service. These will be the different, I think the new kind of model going forward. They will be offered as subscriptions, and people can build their applications on top of these services to do different blockchain actions.
Maybe I'll just combine two other questions before this. So somebody asked, what happens if the doctor or pharmacist system was hacked or their identity was stolen by the hacker? And before this, there was a question regarding quantum computing, saying if any breakthrough in quantum computing would expose or would pose a risk to the blockchain security and the national security of data.
Okay. So for the first question, I think I've kind of briefly mentioned that earlier as well. In any case, if someone gets hacked or their accounts get compromised, it's also so it's really up to the owner to flag this out. Of course, in the future, we can implement more AI to monitor the data to catch these kind of instances, right? But once we are aware of a hack, or once we are aware that identity is stolen, we can immediately make that account invalid, and then we can issue new accounts to the clinic or the doctor. Right. For the second question, so quantum computing can be a threat to blockchain in different ways. However, okay, so there's technology but there's also incentives when we are talking about quantum and blockchain, right? So blockchain is really a stack of data that's being chained up using cryptography. So quantum can unchain this. Quantum can decrypt everything and unchain the whole thing if it becomes that powerful. But then incentive wise, most stakeholders would still uphold the integrity of their blockchain and wants to keep the blockchain data valid. So if a bad actor tries with a quantum computer tries to roll back the whole blockchain or change the data in the blockchain, the other players would still not allow that to happen or will not allow that to be overwritten, right? So that's one part. In terms of the more granular part, like the encryption of the data itself that's being put on the blockchain, can those be decrypted by quantum? Again, yes, right? But then quantum can decrypt this in a very brute force manner, right? So if we are smart about how we encrypt the data and how we actually structure the data that we encrypt, we can still hide information even if the data itself gets decrypted, right? So that is another way that we can address quantum challenges. Of course, in the more greenfield area, a lot of cryptographists are actually looking at quantum-proof cryptography as well, and those are being experimented on in blockchain as well. So once we are able to come up with these quantum-proof crypto methods, then we will kind of be immune against the brute force effect of quantum computing as well.
Very interesting. Fernice, do we have time for one last question?
Actually, it has supposed to end already, but we still have a lot of attendees in line with us. We can take one last question before we end off.
Okay.
Anybody, if you have any question, please type it out under the chat group so that we could attend to it.
Maybe I'll combine two questions before this as well then. So firstly, how does blockchain solve, better versus traditional SQL database system in healthcare? Meaning to say, how does it actually add value over the current existing system? And I think a linked question to that, which is very specific, is how is the e-prescription different from DocuSign, or medical cert is different from DocuSign? DocuSign being that app which is used to sign documents. Right.
Yep. So I can't really answer the SQL question because we are not really using the blockchain data for data analytics. In our use cases, we are actually storing parts of the document data on blockchain and allowing validation and allowing some actions, some automation, but we are not using it for any kind of analytics, right? So in terms of the second question for the, sorry, what was the, can you remind me?
So how does it actually add value over the existing systems?
Oh, right, DocuSign,
and then
right?
And a comparison would be, say, DocuSign.
So DocuSign stores every document centrally on their service. So any kind of contract that you have signed is on the DocuSign server for life, right? So they have this guarantee on their website. They actually store your documents for life so that you can retrieve it at any time. So here we are not storing the documents at all on the blockchain. So for example, in the medical cert case, the medical cert is actually downloaded as a file, as a digital file. It's not stored on the servers. What's stored on the server is a hashed version of that. So which means it's a kind of an encrypted thumbprint of the data, right? So anyone looking at the blockchain will not be able to see that information, right? And they will only, and therefore your privacy will not be exposed. Whereas if DocuSign servers get hacked, of course, they have very high security levels. All these documents that are stored with the servers will be exposed.
Interesting. I do recognize there are other questions, but I think in the interest of time, maybe we can invite the participants to connect with the speakers later. I hope that is okay with all the speakers. And yeah, with that, then I'll pass it back to Fernice.
Okay. Thank you, everyone. We do really have to apologize on how the mic we're having issue with toggling the speakers, but this is the first time. So now that we know what are the issues, we will rectify it. But really thank you, everyone, for staying with us through. Let us know your feedback as well. You'll be directed to a feedback form right after this. We'll be sending you the slides and maybe include the recording in your email. I will also include the speaker's email in as well. So if you'd like to connect with them, please do. If not, thank you very much for your attendance, and we hope to see you soon again.